Okay, so welcome to a specific conjecture lecture. That's quite funny. A conjecture lecture where we're going to find a power rule from our findings from the last lecture, and we're going to use that to our advantage, and we're going to reduce the amount of effort it requires to find derivatives. Okay, so let's begin. Okay, so let me just write this down. Y is equal to x cubed. And we also know one more thing, that when y is equal to x squared, then dy on dx is equal to 2x. Now, if you look closely, there is a pattern, okay? When we differentiate something, x to the power of something, this power ends up behind the x, okay? So it's multiplied to it. Same thing happening here. Same thing happening here. Curious, okay? Not only that, is then the power here is then reduced by 1. Power here, reduced by 1. Power here, reduced by 1. Okay? Now, we can use this interesting observation that we've made and make a conjecture that x to the power of n, let's say any number n, when you try and derive that, okay, we can conjecture that the power comes back here and it is subtracted then by 1. Okay, so this power goes to the back, okay, and then you subtract whatever's at the top, okay. That is, we are conjecturing that that is the method, a shortcut method, to find the derivative of x to the n. Now, I'm going to give you a few seconds to, first of all, give that a shot and see how you go with it. And yeah, just let me know if there are any problems. But regardless, we'll go over this after your break. And yeah. Okay, I hope you gave that a quick shot. But let's just quickly prove this, and then we're done with today's lecture. Okay? So we have f of x is equal to x to the n. I knew I write y equals x to the n before. Again, doesn't really matter. And we're trying to find the derivative. And we think, we conjecture, that it is x. It is like this. Okay? So let's try it. Okay, I almost made the same mistake. I have to use this. Is equal to limit as h approaches 0. F of x plus h. Take f of x all over h. Okay, so now we keep doing the same process. Except here you need a bit of, let's just say, insight. It's not really a trick, but just some insight. And you get this over h. Now, this we can expand this little part here, okay? But how exactly do we do that? We don't know what n is. We could, here's the insight I'm talking about, we could use the binomial expansion theorem, can't we? So we can use that to expand this, and we have n choose 1 x to the n take 1 h, okay, plus n choose 2 x to the n take 2 h, okay, take x to the n. Actually, I should mention another value here, which is plus nn, or we don't need it, it's really just 1. nn h to the n, take x to the n. Okay, so this whole thing, just let's think about it in one line. Okay, all over h. Okay, so let me just differentiate that. Okay, now we know that this and this cancels out again. Very good. And we have all values left have an h in them, so we can take the h's out, factor it, and you're left with this. Okay, 2 da da da. Okay, there's an h here. Da da da. All over h. Okay, again, cancel. Say that h is not equal to 0. And then we let h equal 0. And you are left with this. Because every other value has the h in it. As you can see here, every other value has an h in it. So those values become 0 when we make h 0, and we're left with this. And we know that n choose 1 is just n. n take 1. Okay? I almost made the same mistake again. Anyway, there we go. We have proved our conjecture that we were correct, and the derivative of x to the n is in fact nx to the n take 1. Great. Okay. So now whenever we are asked to find a derivative of a function like this, we know exactly what to do, and we can hammer it away very quickly. Okay, we can find the answers in seconds instead of having to go to the whole first principles thing all over again. It's actually quite nice. From this point forward, I don't think I'll be doing any more first principles in the lectures, unless we come up with something. And you could probably tell in my voice that it's kind of bored of it, and I understand that you people are as well. That's why I want you to just practice it until you don't make any more mistakes. Okay, and then just start using these rules. Okay, we're gonna find more of these rules. Okay, this particular one is called the power rule. We're not the first people to find it. Okay, power rule. Power rule. Okay, as we keep going, we're gonna find more and more rules, and I just want you to start using those rules effectively and finding derivatives. Now, again, same process as always. Go to the worked examples, smash a few questions, and be happy with yourself.